Hello, everyone, and welcome to Jam Academy. We have a very beautiful problem before us. A small box of mass M is pulled to the top of a frictionless half cylinder of radius r by a constant force F as shown. If the box moves at a constant speed, it's important. If the box moves at a constant speed, begin to think, what does that imply? Now, the work done by the constant force, we are asked to calculate the work done by the constant force F to move the box from the bottom to the top of the half cylinder. Remember, the speed is constant, and if the speed is constant, it means that the sum of forces in any direction is zero. So the very first thing that we have to do is to draw a free body diagram of the forces acting on the box. We have three forces acting on the box. One, we have the normal force. This is Fn. And two, we have the weight, which acts vertically downwards. I'm going to call this mg, the weight of the box. Now, keep in mind that this angle is theta. This angle right here is theta. So we can prove geometrically that this angle is also theta, and that's easy to prove. I recommend that you can do this as an extra credit homework and bring it in class, and you will be awarded some extra credit points. So if we resolve the weight, we're going to have here, this is mg cosine theta. This is mg, the sine of theta. Remember that the speed is constant, I'm going to take my x direction. If the speed is constant, it means that the sum of forces along the x direction is equal to 0. In other words, F minus mg cosine theta will be equal to 0, which means that F is equal to mg cosine theta. So this is the magnitude of the force F. Now the question requires us to calculate the work done by the force F. Now keep in mind that the force F depends on angle theta, which means that it is not a constant force. So if the particle, remember, it moves along an arc of a circle, which means that the work done by F is the integral of F dx. We're integrating from 0. Remember, it moves an arc of a circle. So now, if you notice, the force depends on theta, which means that the force itself is a variable force. Now, the work done by any variable force is given by W from 0 to x, F dot dx. This will be equal to the integral of F dx, which is equal to the integral of mg cosine theta dx. Now notice something. F is a function of theta, so we could not integrate theta with respect to x. So we have to convert dx into d theta. Now, what do we note? Dx is actually an arc length, which means that dx is equal to r d theta. And if that is true, then this means that w will be equal to the integral of mg cosine theta bracket r d theta. And we're integrating from 0 to pi over 2 because we're integrating from the bottom to the top. And when the box is at the top, theta is actually pi over 2. So this becomes mgr, the integral from 0 to pi over 2 cosine theta d theta. Hence, w will be equal to mgr bracket sine theta from 0 to pi over 2. Now the sine of pi over 2 is 1 and the sine of 0 is 0. So this will be equal to mgr. This is equal to the work done by the force F. So please, if you have any question or any problem understanding or any difficulties understanding this problem, do not hesitate to ask in the discussion forum below, and we will be able to help you. Remember that F is a variable force, and therefore we will use an integral to calculate the work done by F. I'm going to do another example on this very concept so you could actually crystallize it in your minds. Thank you so much and have a wonderful day. Bye-bye.